Okay, you haven't seen me in a video in a while, or heard me. So what we're going to do is greatest common factor. This is not new. You did this years ago when you were finding factors. Greatest is the biggest, common means the same, and a factor are what am I multiplying together to get that number. So remember when you used to list the factors and you would write them all down in an order. And when you got to 3 times 6, 4 is not a factor of 18, 5 is not a factor, 6 was, but you already have it listed. So you would write those 1 times 24 is a factor, 2 times 12 is a factor, 3 goes into 24 because 2 plus 4 is 6, 3 times 8 is a factor, 4 times 6 is a factor, 5 is not, 6 you've already listed. Now remember 1, 2, 3, 6, those are common factors, but the greatest common factor for these two terms, these two numbers, is actually 6. Okay, that's what we're going to do, but now we're doing it with algebra. So when I look at these algebraic terms and I want to find the greatest common factor, I have to list the factors for each of them. So when I'm listing the factors, look at those numbers first. What is the greatest common factor between those four terms, the numbers? You probably already know it's going to be 2, right? Because 2 times 3 is 6. 2 times 7 is 14. 2 times 21 gave me 42. And then I have that 2 times 1. This is kind of the one that limits it. That made 2 the biggest number. Now you got to look at the other factors that you have because you have other stuff multiplied here. You have to get 6x squared y, 2 x's and a y. To get the 14x y squared, look at the terms you have to multiply. 2 times 7 times x, and there's 2 y's there. This one's going to be an x and a y. There's only one of each variable. Whereas this last one, there's 2 of them. Now let's figure out what's common. Well, we've already decided the 2 is the greatest common factor. What else is common in each of these terms is an x. There is at least one x in each of them. And then there is at least one y in each of these terms. So when I rewrite these expressions, I have actually a 2xy multiplied by 3x gave me 6x squared y. 2xy multiplied by 7y gave me 14xy squared. 2xy, one of the factors, multiplied by 21 gave me 42xy. And finally, 2xy multiplied by xy gave me 2x squared y squared. The greatest common factor is 2xy. The GCF in these terms is 2xy. So you got to look at the number and then you got to look for common variables. In your ISN on 86, you can do this one, 16 to 40, finding the greatest common factor. List what you multiplied and find the greatest common factor. I'm going to do another example of monomials. So again, look at the number. What is the greatest common number factor that goes into 18 and 27? Well, hopefully you go, oh, it's 9, because 9 times 2 is 18. But don't forget, you have 3 more x's multiplied there. And in 27, 9 times 3 is 27, multiplied by 2 x's. What's common is a 9 and 2 x's. So really, I had 9x squared times 2x. I had 9x squared times 3 to get that back 27x squared. The greatest common factor in these monomials is 9x squared. You can do 2 on your own. All right, now I'm going to look at an expression. The first thing I'm going to look for, though, is the greatest common factor between these two terms. So again, I'm going to look at the numbers, and I'm going to recognize that 2 is going to be, actually negative 2 is going to be the biggest number that goes into both of those terms. So I could rewrite these as negative 2 times 7, x cubed, negative 2 times 9, x squared. You may get the hang of this and not have to actually expand it, and just recognize, oops, should have circled that one, what is the common factor here, that negative 2x squared multiplied by 7 plus negative 2x squared multiplied by 9 would get me back to my original expression. The greatest common factor, to factor that out, I am going to say that negative 2x squared must have been multiplied, whoops, lost my x, by 7x plus 9. Oh, look, if I distribute that out, I get negative 14x cubed minus 18x squared. So I just went backwards from the distributive property. But I first had to find the greatest common factor. Look at the number in number 4. What is going to be the greatest common factor that goes into all of those numbers? And then you need to recognize there's also a common x. Try that one on your own. Okay? These are still factors. In example 5, look at the binomials in each expression. This is common. This is so if you take out the common factor of x plus 5, you're left with 4x minus 9. Well, if I rewrote that, it might remind you of this. When I multiplied 4x times x plus 5, I had to multiply 4x by everything, and then I had to multiply minus 9 by everything. It was the distributive property. So really, you have found the common binomial, and you pulled that out, and here's the factor you're left with. All right, so try 6 on your own and to pull out the common factor. Oh, there's a little glitch right there. Check out, watch the negatives. Be careful. I'll see you tomorrow if you get that one. All right, so then the other little thing that you were given in class, the sheet that you were given that had the partner dividing polynomials by monomials. On the back side, there is this, and I want you to practice factoring out the greatest common factor. You need to recognize what the monomial is. What is the common factor that goes into both of these? Well, you should recognize in the number, it's going to be 4. And with the p's, there are a common number, 3 p's in both of those. 4p times 4p gives you 16p to the 4th, plus 4p cubed times 1 will get you back. The greatest common factor in these two terms actually is 4p cubed. And what you would multiply it by would be 4p plus 1. Okay, look at the numbers. What is the greatest common factor between those two numbers? It's going to be 9. So when I take out the greatest common factor, I would be left with x, and then I would have to multiply that by a negative 4. Look, when I distribute it back, I would get 9x minus 36. Okay? So I'm going to just do 4 for you so you've seen one more example. Look at the numbers, right? You should recognize 3 is the greatest number that goes into 6 and 3. Then I have 3 common ends in each of those terms. So to get that back, I would have to multiply this one by 2. 3n cubed times 2 is 6n cubed. And then to get the second term back, I would have to multiply it by n squared when you see it distribute. So find the greatest common factor between both terms, and then look what's common in your letters. All right, so finish this page and the ISN 86 for me, and then you've done a lot of factoring with the greatest common factor.